In the previous video, we saw the demo for the Global Finance application that was deployed to the Hyperledger Fabric. In this video, we will walk through the steps to set up the blockchain network and then connect our application to the network. First, let's clone the GitHub repo to our local machine by copying this command to a terminal. I have already performed this step, so I'm going to move down to the next step, which is packaging the smart contract using Visual Studio Code. Let's open the smart contract folder in VS Code. Remember to open the contract folder and not the base folder for the Global Finance on Blockchain application. Otherwise, you will run into an error when trying to package the smart contract. VS Code will throw an error in this case that says that it doesn't understand the language being used. Press the F1 key in order to see the different VS Code options and choose IBM Blockchain Platform Package Open Project. Once that's successfully completed, click on the IBM Blockchain Platform extension button in the left navigation pane, and it will show our package smart contract under Smart Contract Packages. Right-click on the smart contract and export it to your local machine. Once that's done, we can start setting up the IBM Cloud services. In case you do not have an IBM Cloud account, use the link in the description below to create one. It is now time to create the IBM Cloud services. So I'm here on cloud.ibm.com, and after logging in, you can go to Catalog. We'll start by creating the Kubernetes cluster. So let's go to Containers and select Kubernetes Service. While there are many pricing plans available for Kubernetes service, we are just going to create a free cluster. It expires after 30 days and you'd have to recreate it, but this way you'd be able to have a look at the features of Kubernetes and see how it can be used as part of our Hyperledger application without having to pay any money. So let's click on free and let's give it a nice name. And click on create cluster. Now the Kubernetes cluster takes about 20 minutes to be set up. So while this is happening, we can go ahead and create the blockchain platform. Back on the catalog page, let's create the blockchain platform instance. So we'll click on blockchain platform. And you can see here that there's just one plan available, which says that it's 0.29 USD per virtual processor core hours. However, if you connect this with a free Kubernetes cluster, then you don't have to pay anything. And that is exactly what we've done. We've already started the creation of a free Kubernetes cluster, which is still being spun out for us. So we can just go ahead with this paid plan for blockchain platform, but we will not be charged. So again, I'm going to leave the service name. You could give any name over here, but I'm going to leave it as is and just click create. So when this is being created, it walks you through a couple of steps. And let's see. So it says welcome. Let's click on let's get set up. And it says create an IBM Cloud Kubernetes Service Cluster. Now we already have one created, right? So we don't need to create this. We could just connect to an existing one. So let's move on to the next stage, which is link in IBM Cloud Kubernetes Service Cluster, and click on next. And it's going to keep checking for an available cluster. And at this point, we do have kubecluster, but it's still in the deploying state. So it won't let you connect to the Kubernetes service cluster at this moment. Remember how I said it would take about 20 minutes? So let's check back in 20 minutes. And once the Kubernetes service cluster has been created for us, we'll come back to this screen and connect blockchain platform with the kube cluster. So we've been waiting for a couple of minutes, and now let's go back and check if our IBM Cloud Kubernetes Service Cluster has been spun out. So going back to the link in IBM Cloud Kubernetes Service Cluster screen, you can check for kube cluster, and it does not show that error saying it's still in deploying state anymore or pending state anymore. So now that we have that available, we can just select the kube cluster here and click on next. And once that completes, we should be able to move on to the next stage, which is launching the IBM Blockchain Platform. The cluster has been linked to the IBM Blockchain Platform instance. Now we can go on and launch the IBM Blockchain Platform console. Now we can start building our blockchain network on IBM Blockchain Platform. Let's start by creating a certificate authority for our peer organization. So on the Notes tab in the left-hand pane, let's select Add Certificate Authority. We're going to create an IBM Cloud Certificate Authority with the display name of org1ca. The enroll ID and enroll secret for this, I'm going to give it as admin and admin PW. You can click Add Certificate Authority to create this new certificate authority. It takes a couple minutes for the certificate authority to set up. This green icon here indicates that the org1ca is now up and running. So now we can go in and associate the org1ca admin identity. So let's click on Associate Identity. Let's give the enroll ID as admin, the secret as admin PW, and we'll give it the name of org1ca identity and click Associate Identity. Once the admin identity has been associated with this CA, we can go in and use the CA for registering identities for org1 admin and peer1. So we'll click on Register User and start with org1 admin with an enroll secret of org1 admin PW. We leave the type of this user as client and we will use root affiliation. Just let's click on Next. And without adding any attributes, we'll click on Register User. Next is peer1. So we'll click on Register User again and type in peer1 as the enroll ID and peer1 PW as the enroll secret. The type of this particular user is a peer, so we'll change the type. Continue using root affiliation as before and click Next and Register User. The next step is to create the org1 MSP. So for that, we'll go to the Organizations tab on the left-hand navigation pane and select Create MSP Definition. We'll give the name for this MSP as org1 MSP and the ID will also be org1 MSP. We'll select the root certificate authority as org1ca and the enroll ID and secret would be org1 admin and org1 admin PW. Let's give this identity a name of org1 admin and click Generate. We'll export the identity that was created and then click on Create MSP Definition. Now that the MSP has been created, we can go back to the Notes tab on the left-hand navigation pane and click on Add Peer to create our peer. Let's create an IBM Cloud peer with the name of peer org1. The certificate authority will be org1ca. The peer enroll ID is peer1 and the secret is peer1 PW. We'll select the organization MSP as org1 MSP and click Next. And we will associate the org1 admin identity that we created a few minutes ago with this peer. Once everything is verified, we can click on Add Peer and that will ensure that a peer is created. The next step is to create the orderer CA and add the ordering service to our network. We'll start by creating an orderer CA. Let's click on Add Certificate Authority and create an IBM Cloud Certificate Authority with the display name of orderer CA, an enroll ID of admin, and an enroll secret of admin PW. Once the orderer CA is up and running, we can go in and register the admin identity. So let's associate the identity called admin with an enroll secret of admin PW. Let's give this identity a display name of orderer CA identity and click Associate Identity. Once that's done, we can use the CA to register the users for orderer admin and orderer1. So let's click on Register User and create the user for orderer admin with an enroll ID of orderer admin and an enroll secret of orderer admin PW. This user is of the type client, so we'll leave this as client. We'll use root affiliation and click Next, and without adding any attributes, we'll click on Register User. Next, we will register the user for the orderer. So let's go in and type in orderer1 as the enroll ID and orderer1 PW as the enroll secret. The type of this particular user is an orderer, so we'll select that, use root affiliation and click Next. Without adding any attributes, we will select Register User. The next step is to create the orderer MSP. So for that, we'll go to the Organizations tab on the left-hand pane and select Create MSP Definition. We give this MSP the name of orderer MSP with an ID of orderer MSP. We'll select the root certificate authority as orderer CA, and the enroll ID and enroll secret that we'll provide here would be orderer admin and orderer admin PW. The identity that we create, we're going to name it as orderer admin. Let's click generate. Let's export the identity to our local machines and create MSP definition. Now that the MSP has been created, we can go back to the Notes tab and create our ordering service. Let's click on create an IBM Cloud Service ordering service and give it the name of orderer. The certificate authority that we select would be orderer CA. The ordering service enroll ID is orderer1 with the enroll secret of orderer1 PW. The MSP that we've created is orderer MSP. And the identity that we have created is orderer admin. Let's click next, verify everything, and click on add ordering service. Once the orderer is up and running, we can go into the orderer and add org1, which is the organization we created a few minutes earlier, as a consortium member to this orderer. So let's click on add organization and select org1 MSP and click add organization. The next step is to create the channel. In the left-hand navigation pane, let's click on channels. And on the screen, let's click create channel. We'll give the channel name as my channel. And select orderer as the ordering service. We'll select the channel member to be added as org1 MSP and click on add. We'll set the permissions as operator. Scroll down to channel creator MSP and select org1 MSP and the identity as org1 admin and click create channel. The next step is to join the channel. So we click on join channel, select the ordering service, which is orderer, click next, type the channel name that we have just created, which is my channel, and click next. And then we select the organization to add to this channel. So we need to click on this one over here to see that it has been selected. Once that's done, we can click join channel. We can now go in and install our smart contract. So in the left-hand navigation pane, let's select smart contracts and click on install smart contract. Click on add file and then select the smart contract that we had exported from Visual Studio Code. Click on install smart contract. Once the smart contract has been installed successfully, it should be visible here under the installed smart contract section. Click on the overflow menu and click instantiate. To instantiate the smart contract, we'll have to select the channel on which to instantiate it. Next, we need to select the members for the smart contract. We're going to select org1 MSP. We don't want to set up any private data collection at this point, so we're going to skip this step and just click on next. And in order to instantiate the smart contract, we need to provide the function name as instantiate. There are no arguments for this function, so we'll simply click instantiate smart contract. Once the smart contract has been instantiated, you can find it here under the instantiated smart contract section. Let's click on the overflow menu over here and click on connect with SDK. We'll have to select our org1 MSP as the MSP for connection. We'll select org1 CA as the certificate authority and click on download connection profile. This connection profile is what will be used to connect the application, the Node.js application, with the blockchain network on IBM Blockchain Platform. Once that's downloaded, you can click on close. Next, we will create an application admin that can interact with our Node.js application using the SDK. So let's go back to the Nodes tab and go to org1ca. And in here, we will register a new user called app admin with the enroll secret of app admin pw. The type of this user is a client. We'll use root affiliation and click next. We'll add a new attribute here called HF registrar roles and enter the value of star and click register user. Now that our blockchain network has been completely set up, we can go ahead and connect the network with our application. For that, we need to copy the My Channel Global Financing Profile.json file that we had just downloaded from Blockchain Platform into the Global Finance on Blockchain repos local copy that we are maintaining on our machine. So let's go into that folder and go to Web App, Controller, REST API, Features, Fabric, and paste that file here. Now I'm going to open this folder in VS Code so that we can open the config.json and the My Channel Global Financing Profile.json files, as we have to edit these files in order to connect our application with the blockchain platform. So back on Visual Studio Code, I'm going to add a folder to Workspace, and I'm going to select the Web App folder, add that in. And once that's done, I will be able to open those two files that I had mentioned, which is the My Channel Global Financing Profile.json and the config.json. Now the config.json file is the one that is used to connect the application to the blockchain network on IBM Blockchain Platform. So we need to make some changes to this file here and verify that everything in this file is correct so that we can connect to the network on blockchain platform. So let's see. The channel name has been provided as My Channel, which is the same as the channel name that we had provided. The smart contract name is Global Financing. We can leave it as is. The connection file name should point to the file that was downloaded from blockchain platform. And in our case, it is My Channel Global Financing Profile.json as well. So we're going to leave that as is. The app admin and the app admin secret correspond to the app admin user that was created just a few minutes ago on blockchain platform for connecting the application to the blockchain platform. We had provided the app admin user ID as well as the secret as app admin and app admin PW. So that's correct as well. And the org MSP ID should point to the org1 MSP, which we had created, which is also exactly like we had created in blockchain platform. The next three pieces of information, that's the CA name, the peer name, and the orderer name, are pieces of information that we can obtain from the My Channel Global Financing Profile.json. So for the CA name, we can go back to that file, and in the certificate authorities section, you can select this here, which is an IP address followed by a port number, and paste that in as the CA name. Likewise, the peer name can be found here under peers. And the orderer name can be found here under orderers. The peer name and the orderer can also, and the certificate authority can also be found from this section over here. Now that those three have been updated, we can move on to the next one, which is gateway discovery. And gateway discovery needs to be set as enable true and as localhost false in order to connect the application to a network on blockchain platform. Once all of this is done, we can save this, and these changes will now ensure that we can connect our application to blockchain platform. The only thing left to do now is to run the application. So let's go to a new terminal and open the web app folder in the terminal. And let's say npm install to install all the node dependencies. The next step is to run the enroll admin.js script. So node enroll admin. And that is going to enroll the app admin user that we had created and import it into the wallet. All that's left now is to run the application. So we can say npm start, and that is going to start our application and run it on localhost 6001. So let's go here to the browser and open a new tab and go to localhost 6001. And this is the landing page for the Global Finance with Blockchain application, as we had seen in the demo video previously. We can go in and say preload network, and that would start preloading all of the users in the network. We can also verify everything that's happening in the terminal here. You can see that it's registering all the sellers, buyers, suppliers, and so on. Once autoload is complete, we can see that it says the autoload has been successful, and we can go to roles, load unified user experience as before to see all the order statuses and then take any actions that we want to as part of the demo.